Good afternoon and welcome to RDA's Tech Talk. Today's topic will be Enterprise Data Warehouse Architectures in Azure. RDA's Tech Talk series is designed to be a 30-minute technical presentation around a current technical topic, and for today's talk we will have about 25 minutes of presentation and then open it up for questions at the end. So before I turn it over to our presenter for today, just want to cover three things. One is you'll be able to send questions at any time using the GoToWebinar Q&A interface, and we will cover as many of those as we can through the end till our 12:30 time slot. And then for questions we're not able to address today, we can post responses in our TechTalk LinkedIn group. We will also use this group to provide access to speakers pre- and post-conference for any session questions, as well as sharing out materials. Secondly, we will be recording today's session, so you can review that again or share with others. And then thirdly, at the end of the presentation, when you exit the GoToWebinar, a survey window is going to pop up with just a few questions to help us out and enhance our experience for next time. So if you could take a moment to respond, we would greatly appreciate it. And to thank you, we will pick 2 lucky survey responders to receive a $15 Papa John's gift certificate for helping us out. So with that, we'll get to the reason why you all joined us today. I'd like to introduce our speaker, Shruti Sinha. Shruti is a project manager for RDA's DC delivery team, responsible for successful customer engagements. Her portfolio of clients includes large public sector and commercial organizations. Her technical expertise is in cloud-based solutions for the enterprise, Office 365, Microsoft SharePoint 2013, and SharePoint Online. Business Intelligence with SQL 2012, and Power BI with Office 365. Shruti has numerous technical certifications to her credit and has earned a master's degree in organizational behavior as well as an MBA from Robert H. Smith School of Business at the University of Maryland. So with that, I would like to now thank Shruti for joining us today and turn the presentation over to her.
Thank you, Patty. Appreciate everybody's joining. Hope you enjoyed today's presentation. Let me dive right in. As Patty said, we're going to talk about enterprise data warehouse architectures in Azure. A quick look at what we're going to cover for the agenda. We'll go over some basics about the data warehouse, which most of you are probably aware of, but just wanted to do a quick overview of the logical components, the data warehouse model, what are the various solution architectures people talk about. The physical architecture, and that becomes important today because of the various solution options we have because of the new trends in place. And then we'll get into the deployment topologies and talk about what SQL Azure has, what you have when you talk about infrastructure as a service and SQL Server VMS. And then, of course, we'll open it up to Q&A. Feel free, as Patty said, at any time to raise your hand virtually, and we'll try and cover all the questions as they come along. So starting off with a data warehouse and its logical components. As you can see on the screen, any data warehouse has many layers within it. We have the data source layer, which basically is the different types of data that can be sourced. The data extraction layer, where we would actually be pulling the data for the source. And at this point, we do minimal cleansing of the data. The staging layer, where the data sits prior to being scrubbed, and then comes the ETL layer. And this is where we are actually applying the logic to transform the data in an analytical way. The data storage layer, data logic layers, where the actual business rules would be stored once you have the data available, because you want to, before you actually present the data using whatever presentation layer you're using, you want to make sure you apply certain business rules to it. The metadata is where you would store information about the data warehouse system, and of course the system operations is, how the data warehouse system operates, what are the ETL job statuses, and etc., all of those kind of details. So the question that comes up is, how do these layers, the logical components, translate into the data warehouse model? Well, as you can see, you will have many source systems, as this image says. It can be an ERP system, it can be legacy data, it can have any OLAP source that you may have. But on top of this, you need to have platform infrastructure that can address various infrastructure needs. For example, the security aspect. Are you going to administer it? Are there any portal needs? Are there any compliance needs? And this, in turn, the platform infrastructure that you have will in turn help you address a lot of the reporting needs your organization may have, the analysis needs that they may have. It may kick off workflows, and of course performance management. All of this works together to bring together, so all of this underlies what exactly some data warehouse would look like. Moving forward, how does one implement this into a solution architecture? Okay, so we just talked about what the data warehouse model should address, what are the business needs it should fulfill. So what is the kind of solution architecture it may have? As you can see from this image, there are many components of it. But the fundamental solution architecture is overall explained by this image. You have the OLTP pieces, which is the data sources. You have the central section where you're actually doing the data transformations. You may have the data warehouse. You may have a data mart, and you may have analytical services. For example, you may have cubes. You'll have reporting services, and then the final is the presentation stage, where you're actually delivering the results to the end user based on what they need. They want to see data in an Excel spreadsheet. They want to be able to see data via some standard SSRS reports, the various ways of presenting the data. And as I use the word standard SSRS reports, I also would like to state that the definition of standard has changed. There's nothing just called the usual reports. Different needs require different standards. Another way of looking at the solution architecture is a simpler view of it. Basically, as you can see in this, their data sources, you have the section where we're talking about what exactly is the data processing and data storage needs that you have and how you can do it, and then the final presentation there. This is how Microsoft actually breaks out how an architecture of any particular data warehouse solution should be looked into, and specifically the reference architecture for their fast-track solutions would be the central section where we're talking about how the staging databases and the data warehouse and the data mart actually should be set up. Talking about fast-track architectures, we know that fast-track, as you know, the fast-track actually is Microsoft recommended solutions and reference configurations that they provide that gives guidance for choosing the right system and then configuring it for the right workload. Any data warehouse, whenever we talk about it, we're talking about some massive database sizes over here. So Microsoft has come up with certain recommended architecture for the data warehouse, and whether it's any kind of massive parallel processing system or whether we talk about multiple servers participating in a scale-out architecture, you can have many servers that can participate in resolving any one query that your end user gives. And whether it's a 64-bit multi-core processor or a single symmetric multiprocessing server, any kind of system that you have, how it scales to handle large applications such as data warehouse is one of the key factors that help decide what the architecture or what the physical architecture should be. Basically, whatever your BI solution size be, whether it's a small relatively or whether it's much larger, it can go. The system still needs to be optimized to handle the concurrency, the volumes, and the complexity of the data warehouse workload. This in turn leads us to the physical architecture that we're talking about. How do we support all of these needs? It has to be able to scale up, it has to be able to scale out, it has to be able to handle the different kind of needs. So a typical solution architecture for a BI environment includes, as we said, the ETL processes. You need some temporary storage for the staging environment. You have the data warehouses, data mart. Then you have cubes, presentation layer, and the dashboards and the analytic view. For smaller solutions, some of those components can be co-located on the same physical machine. But we all know everything cannot fit on the same machine. For enterprises and for large organizations, a vector architecture choice is to actually distribute this over separate servers. If one were to look at the physical architecture and how it gets distributed, you might have SAN storage, where you're actually storing quite a bit of the information. They have the actual data warehouse, the data staging, and the bulk loading piece, which is a SQL Server. You might have additional SQL servers for different data marts that you may need to create, or the cubes that you may need to create. You would have ETL services running, maybe using SSIS that need to be used for loading the data. And finally, whether it's your reporting services database, whether it's your SSAS cubes, and if you're presenting through SharePoint, you may have SharePoint databases, etc. So Overall, you have supporting systems, you have BI data storage systems, and then you have presentation layer systems. All of these in an enterprise usually get spread across a multiple server farm. This is how things happen traditionally, but in today's day and age, there are many things additional that we need to take into account. As we all know, the volumes of data that we're talking about today is much more than what we had earlier. In addition, there are often needs for real-time data. We also have different types of data sources and types. Earlier you just had ERP systems or maybe OLTP systems, but now you have, different types of, maybe you have social data, you have sensor data, you have data from your logs from your various websites that you may have. And of course, there are various cloud-based data sources or cloud-based data targets that you may need to handle. So these kind of topologies may need many servers, and you may need more than one server for each of these layers. This topology can be built on premises, it can be in the cloud, or it can be a hybrid solution. So moving through these different topologies actually is what is going to tell us what exactly your data warehouse architecture should look like. So let's jump a little bit more into some example deployment topologies that you may have. You may have scenario one where you have a single virtual machine. In that single virtual machine that may have analysis services, reporting services, it may have a SQL Server Database Engine and data sources that either are read from a separate machine or on the same machine. This, as you can imagine, is going to be a really small enterprise. This is not something very large. It does not sound like high-level enterprise database needs or data warehousing needs. Slightly larger than that is the two virtual machines, as you can see in the diagram on the bottom right. You could have one where you have the analysis services, reporting services, SQL Server on a single machine. You may include the report server databases on it, and you may have a second virtual machine that is actually the data source that we're talking about. So basically, you're splitting your needs into separate virtual machines. And again, as I said, the virtual machines can be Windows Azure-based. If you had an on-premises solution, your virtual machine could be on-premises as well. A hybrid topology would be something that goes across your on-premises and what Windows Azure provides for you as well. So in a hybrid scenario, as this diagram again says, the Windows Azure virtual machines may have things like analysis services, reporting services, the SQL Server Database Engine. That can be in Azure, and on-premises would be your data sources. And of course, the virtual machine needs to be joined to the on-premises domain through Azure Virtual Networking or any other kind of tunneling solution. Depends on how exactly you want to take your data across the network. The network plays a big role in determining what your topology is, because based on how much data you want to move across, what is the kind of data you want to move across, when you need to move the data across, that again determines the different topologies that you may need to use. Depending on the solution you use, of course, we need to address different types of challenges. We're moving these across networks, so how do you reduce the network latency of the data that is accessed? How do you make sure that you keep the data close to the applications that access it? Because we all know if there are multiple hops that need to be done to get to the data source that you're trying to get to, there may be different needs. If a service is running in a data center and it uses data held in a local database stored in the same data center, then you've basically eliminated the latency and the reliability issues that may be associated with sending data across the network. But you still need to consider the fact that whenever you're talking about sending data across the network, there may be situations that you may introduce inconsistencies. Replication is ideally best suited to situations where the data changes relatively infrequently or where the application logic can cope with slightly out-of-date information as long as it's eventually updated. And this is often what a data warehouse is used for. So it's not your online transaction system. It's not a case of, you're trying to run an application where the customer's shopping cart and the dollars and the cents associated with this have to be absolutely in sync with what's there in your report, because it's not 100% in time sync. The scenario is more like you're looking at the end of a quarter, or you're looking at the end of the day also maybe, and you're trying to see, okay, what were my sales for the day, what were my numbers for the quarter, what were my numbers for the month. This kind of information is something that can lag a little bit, but as long as it gets updated, you should be fine. So what are some of the topologies that help us address some of these challenges? We talked about replicating data sources, data across different sources. So this is one scenario where you have a simple topology, relatively speaking. And in this case, as you can see in this form, the implementation in this use case just basically copies all the data from a data source to other instances of the same data source, whether these data sources are located in the cloud or on premises. So in this scenario, the application running on premises and services running in the cloud, they can query and modify any of the data. They can connect to the most local instance of the data and perform the queries and make the necessary updates. And at some point, all of these updates get transmitted to all of the other instances of the data sources. And of course, we have to make sure that all of the updates are applied in sync. So as you can see over here, you have applications running on-premise on the on-premises infrastructure that update the on-premises database. The data gets replicated across data center A and B, and then there may be services running in the cloud that query and update the local databases in the cloud. Basically, the data must be replicated and synchronized between the databases in the cloud and on-premise. Another topology, which is slightly more complex, would be that where your master repository is in on-premises, and you have data centers set up in the cloud, and you have a one-way synchronization. In this scenario, the one-way synchronization is needed so that your master is always up to date, and you're basically pushing the data into your data center, whether it's data center A or B, based on your needs. The relevant changes from the master database would get replicated in each of the databases in the cloud. The services running in the cloud would query the local databases in the cloud, or they could also go and query the master database on premises if the data is not available locally. And finally, the services running in the cloud, they can update the local database, but they can also send an update request to the application running on premises to maintain the master database. And this is needed because, as you can see, the master database is just doing a push from a database to database. So the master database on premises pushes to data center A or data center B, and you need some sort of service that goes and makes sure that any changes made within data center A and B come back into the master database. And that's where the services play a role over here. So when we're talking about all of these different types of data centers and keeping data in sync, what are some of the options one may have? So that's where SQL Azure Data Sync is something that's really useful. It has many benefits, it provides elastic scalability, which basically means that the SQL Azure service runs in the cloud and it scales automatically as the amount of data and the number of sites participating in the synchronization process increase. It has a very simple configuration mechanism. There's a management portal where you can define the synchronization topology, and the portal provides many wizards, etc., to step through the configuration process, and you can indicate whether the replication could be one-way or bidirectional. The portal basically provides a graphical view of your topology and what its current health is. You could schedule the synchronization. Basically, you can say how frequently do you want it to occur, and you can change the frequency as well. As you all know, often you set up a schedule, it works initially, but you realize, you know what, this is not the ideal scenario that you would want. So you would want the management portal to give you the options of maybe doing an immediate synchronization or scheduling the synchronization for a slightly later time. And of course, it has the ability to handle conflicts. It helps you select how you want to resolve any of the conflicts that you may have when doing synchronization. And it will, of course, log everything, all of the events and operations. So SQL Azure Data Sync is something that is very useful. It has many features that are beneficial for keeping our various data sources in sync, whether it's, you have a scenario of keeping multiple data sources absolutely in sync, or you have a scenario of having a master database and separate data centers within the cloud when we're talking about a hybrid solution. Another approach could be, instead of using, because whenever we talk about SQL Azure Data Sync, you're talking about SQL Azure databases as well. Instead of that, you could go down the infrastructure as a service solution approach. Basically, in this, you would set up the data warehouse and utilize availability groups to synchronize the various databases instances. So you have a database instance, whether it's on-premise or in the cloud, and you have other database instances in a separate location, and you can set up an availability group. An availability group, of course, needs to be set up only with infrastructure as a service. You don't have that option with SQL Azure. Most SQL Server high-availability disaster recovery solutions are supported in all Azure virtual machines, both as Azure-only solutions and also as hybrid solutions. So if one looks at what are some of the IaaS topologies that are possible, so what you could have is one situation where you have a Windows Server failover cluster that you've set up, and basically you have all the replicas running in Azure VM for high availability, but all of them could be within the same region. So you need to configure a domain controller in addition to the SQL Server virtual machines, because setting up Windows Server failover clustering requires Active Directory. And because they're all in the same region, you could set up a synchronous commit between the replicas. Another topology could be where you have availability replicas running across multiple data centers in in Azure VMs. And this really helps in disaster recovery. If one region goes down, you still have the other region available. The cross-region solution basically is going to help you against a complete site outage. The chances that all of the regions will go down at the same time are slightly remote. And when you have it set up this way, you can set up an asynchronous commit between the replicas. You could always set up a hybrid solution where you have a primary, maybe on-premises, and a replica in Azure. And in that case, based on your needs, you may set up the availability group across the on-premises and the Azure topology as well. Overall, I think what we can say is that whether you have an Azure-based data warehouse, whether it's an SQL Azure solution or whether it's a IaaS SQL Server VMs-based solution, both of those solutions are able to support enterprise needs. If you go and look at case studies for enterprises that have implemented data warehouses in Azure, there are many different types of ways that you can actually implement this. You always have the choice between SQL Azure and SQL Server VMs. Based on the choice, there are various topology options that are available. And overall, enterprises, as you can imagine, you need to be able to identify what exactly is your strategic objective that you're trying to achieve. And those objectives are going to drive whether or not you should go with a SQL Azure solution or whether you should go with the SQL Server VM solution. And once you've set up a solution, how do you keep all of your data in sync? Should you use, with SQL Azure, should you make sure that you're using SQL Azure Data Sync, or should we set up an availability group? Again, many options, but bottom line is they're all enterprise grade, and the solution that you choose has to be determined based on what exactly is important to you. We are about at 12:23 according to my watch. At this time, I'd like to open it up to questions, if any.
Thank you, Shruti. Again, if you do have a question, you can feel free to use the GoToWebinar platform there and submit your questions. And while we're seeing if we have any others, I do have one or two that I can start with. So Shruti, what are the pros and cons of SQL Azure and SQL Server on a Windows Azure virtual machine?
So as you can imagine, that question can be its own tech talk by itself. It's a pretty long answer. But to give you a very brief response, I would say that basically with Windows Azure, when you talk about infrastructure as a service, you as an enterprise would install the operating system on the virtual machine. Your application in that case can do whatever you want for as long as you want it, as long as you stay within the rules of Windows Azure. So when you install the operating system, I don't mean actually go and install it. I mean that you actually control it. You can choose whether you're going to use one of the standard images that Windows Azure provides for the various virtual machines for SQL Server, or set up your own, build it from scratch. But basically, you have control of the entire box. How you use it is up to you. You can basically install SQL Server on the virtual machine and have a full range of all SQL functionality. In the SQL Azure aspect of the implementation, this is where it's called Windows Azure SQL Databases, and it basically provides a database as a service solution. And at this point, you've gotten away from having to install SQL Server and manage it. What you actually do is you do have most of the functionality that SQL Server provides, but not all of it. And you don't have all of it, it's because this is basically a shared offering. So if you go down the SQL Azure route, you're basically using an offering that Microsoft provides to other organizations as well. Based on your needs, it may be exactly what you want. You want to stay away from having to go ahead and set up VMs and manage them and patch them and all sorts of this. Instead of that, if you actually just want to address certain business needs that can be addressed via SQL Azure, that's possible. But the bottom line is one needs to be aware of what exactly is the different types of SQL functionality that are important to you to deliver your solution, and let that drive what exactly is the right solution for you. So again, in brief, if you do SQL Server on a Windows Azure virtual machine, you get the full breadth of SQL Server features, full breadth of SQL Server functionality. If you're doing SQL Azure, it's slightly limited.
All right, Shruti, and then let's see, another question is, what is the difference between an asynchronous commit and a synchronous commit in an availability group?
So basically an availability, the availability mode is basically a property of the replica that you're working with. The availability mode determines whether the primary replica waits to commit transactions on a database till a secondary replica is written to the transaction log, or it does it the other way around. Basically, always on availability groups has two availability nodes. In the asynchronous way, the availability replica uses its availability mode, and in this, the primary replica commits the transactions without waiting for getting an acknowledgement from the secondary. If you have a synchronous mode, the primary replica is actually waiting for a commit to happen. It needs to hear back from the secondary replica, and that will happen only after it's written to the log and they finish hardening the log. And when that happens, that's when the primary replica would move forward. The synchronous commit ensures that once a given secondary database is synchronized with the primary replica, committed transactions are fully protected, and only then can the next step be taken. It's a function of whether you want, how tightly you want your two, the primary and the secondary, to be in sync.
Perfect. All right. Thank you, Shruti. All right, folks. Well, we are just up against our time here, so I'm going to go ahead and close us out. If there are any questions that we did not get to, we will try to reach out and include those on our LinkedIn group. Our next presentation is scheduled for Wednesday, December the 3rd at noon, and we're going to be presenting SharePoint 2013 on-premises and in the cloud. And additionally, for those of you that might be local to the Reston, Virginia area and are interested in the Azure topic, RDA and Microsoft are hosting an Azure boot camp. So it's being held on Wednesday, December the 10th at the Microsoft office, and it's going to be a half-day free program that consists of 2 tracks, an enterprise track and a developer track, with 3 sessions that will run within each. So if you're interested and not already registered, you can sign up by visiting the events page of our website, rdacorp.com, or contacting marketing@rdacorp.com for further details. So thank you again. We appreciate your time. Have a great rest of the day, and we look forward to you joining us next time.
Thank you, everyone, for joining.